Alright, now we get into the meat and potatoes of the CCNA. In the second part of this fourth module, we're going to go ahead and talk about subnetting. Now, I'm going to go ahead and warn you that this is probably the most important presentation in the series, and so if there is stuff that you are not clear on by the end of this presentation, you'll need to be 100% clear on that before you continue on with the CCNA trainings. This is very, very important. So important, in fact, that I actually have an entire slide dedicated to saying how important it is. I mean, seriously, the CCNA requires you to be a very fast, efficient, and good subnetter, and you ought to be able to perform subnet calculations with very high speed and very high accuracy. So I encourage you, again, I provided a lot of materials on the Facebook group, so you should go back, you should do these exercises. There are entire appendices devoted to subnet practice, so you should be able to practice these and come up with problems for yourself. Try to figure out some of these things. Figure out what addresses work and don't. But again, this is very important, so I highly encourage you to practice this as much as you can. Alright, so now we actually can break down what an IP address is. Basically, every IP address consists of a network portion and a host portion, and so the network portion is going to be determined by the first octet and what we call classful addressing. Classful addressing, basically, the first octet, the number before the dot at the very beginning of the IP address, will determine the size of the network portion and the size of the host portion. And so for a Class A address, the number at the beginning will be for a number between 1 and 126. And if this is the case, then the network part is actually only the first octet, that number 1 or 126. And the other three octets, the last three numbers in the IP address, will be used for the hosts. In the case of a Class B address, we'll actually use the first two parts, the first two octets to determine the network, and the last two will determine the host. And so, for example, Wichita State uses the IP address range 156.26, and that would be considered the network, the classful network. And so all hosts on the Wichita State network will begin with the two octets 156.26, and you'll notice that 156 falls in this range listed here, and therefore is a Class B address. The final class is the Class C address, and those are going to be all addresses from 192 to 223. So, for example, the ever-famous 192.168.1 would be considered a Class C network. And you'll notice I said the first three octets there because the first three octets are considered the network portion. The last octet is reserved for hosts. And so the number of hosts in that Class C network, the number of the first host is going to be 192.168.1.1, and then the last host is going to be 192.168.1.254. Why don't I say 255? 255 is the highest possible value you can have in an octet. We'll talk a little bit about that here in a second. So now I want you to look at this list of numbers, keeping in mind that the address ranges go from 0 to 255, and see what's missing from the list above. Try to figure it out yourself and do a little bit of research before you pause the video and then keep going. So 127 is removed from this, and actually 127 has a special purpose. It's reserved for local loopback addressing. You'll recall when I talked about inter-process communication, when I talked about Layer 7, the whole point of Layer 7 is designed to be from one process to another, and that may or may not be across a network. While they can use an IP address to talk to each other, they may just end up using different IP ports or different TCP or UDP ports on the same loopback address. And so 127 is reserved for these internal loopback addresses. And this interface, this loopback interface that is on a computer, will almost always be up, and it's used primarily for inter-process communication. Another range that we're missing here is the range from 224 to 239. And that is reserved for IPv4 multicast. These can be considered, I'll put Class D in parentheses out there. It's not really a class because there's no network portion or host portion in a multicast address. It's simply referred to as a multicast address. And so it could be anywhere between 224 and 239. And there are several different addresses, Class D, some sort of multicast addresses that we'll talk about over the course of these presentations. The last range is from 240 to 255, and that's reserved for future use. It's Class E. You probably won't see these implemented. You may eventually end up seeing these implemented for some later IP networks. Now that we're kind of running low on IPv4 addresses, you may see some of these used. And the highest address, where all of the octets are set to ones, is considered the IPv4 broadcast address, and this will be not only sent to all particular hosts in a particular network, but this is also sent to all networks. And so IPv4 broadcast is all ones, just like an Ethernet broadcast was considered where the MAC address is all ones. So now we can talk about some special IP addresses that are reserved. And so the IP